Alright, so now let's consider the nature of radiations. Let's consider the nature of radiation. The three main radioactive particles are the alpha, the beta, and gamma radiation. Is that okay? Now let's consider the description of these three radiations. So let's take the first one. So let's take one, alpha radiation or alpha particle. So the alpha particle has a symbol like this with a mass of 4 and a proton of 2, or we use the helium nuclide. Is that okay? In nature, the alpha particle is described as the ionized helium nuclide. The ionized helium nuclide. So the alpha particle is described as the ionized helium nuclide. Is that okay? This is a symbol of the alpha particle. Is that okay? This is a symbol of the alpha particle. The nature is the ionized helium nuclide. So this is the helium, He, with its ionic form, 2+, with a mass of 4 and a proton of 2. Is that okay? Now, what is the electrical charge of the alpha particle? It has a charge of +2. It has a charge of +2. Is that okay? Now, what is the effect of electric field on an alpha particle? Since the alpha particles are positively charged particle, and its mass, it has a mass of 4, so it is slightly deflected towards the negative plate due to its slight heavy mass. It is slightly deflected towards the negative plate. So in electric field, it is deflected towards the negative plate. It is deflected towards the negative plate. Is that okay? It is slightly deflected towards the negative plate due to its mass. Is that okay? With the magnetic field as well, it is deflected. Since it is a charged particle, it is deflected in the magnetic field. It is deflected in the magnetic field. With regarding the radiative penetrating power, the alpha particle has a very low penetrating effect. It has a very low penetration effect. It has a very low penetration effect. The alpha particle has a very low penetration effect. So that is the basic information from the alpha particle or alpha radiation. Now let's move on to the second one. We can talk of the beta particle. The beta particle is denoted like this. This is a symbol of the beta particle. Is that okay? So like this. This is a beta particle. And then this is the alpha particle. This is the alpha, and then this is the beta particle. Is that okay? The beta particle can also be represented using E, an electron. Is that okay? So this is the beta, and this is the alpha. So alpha, beta particle. Is that okay? Now let's go through the nature of the beta particle as well. The beta particle is described as a high-speed electron. So as the alpha particle is described as the ionized helium nuclide, the beta particle or the beta radiation is described as high-speed electron. High-speed electron. Is that okay? It is described as a high-speed electron. So it looks like this: E with a mass of 0 and a proton of -1. Is that okay? Please, are you following? Yes. So that is the description of the beta particle or the beta radiation. What is its electrical charge? Its electrical charge is -1. Is that okay? Its electrical charge is -1. Alright, now let's talk about its effect regarding the electric field. Since the beta particle is negatively charged, it is deflected towards the positive plate. It is deflected towards the positive plate. So deflected towards the positive plate. It is deflected towards the positive plate. Is that okay? It is more deflected as compared to the alpha particle, which has a slight heavy mass. So it is slightly deflected towards the negative plate. For the beta particle, it is deflected easily towards the positive plate. Is that okay? And then, since it's a charged particle, in a magnetic field, it is deflected. In a magnetic field, it is deflected. The beta particle has a good penetrating power compared to the alpha particle. So very good penetration effect. Very good penetration effect for the beta particle as well. Is that okay? So now let's look at the last radiation. So that is the gamma radiation. The gamma is represented like this. It has a symbol like this, with a mass of 0 and a proton of 0. So let me draw it here. So this is the gamma radiation. Is that okay? That is the gamma radiation. Now, what is the nature of this gamma radiation? It is described as an electromagnetic wave. The gamma radiation is described as an electromagnetic wave. So the gamma radiation is described as an electromagnetic wave, as the beta described as high-speed electron, and the alpha described as an ionized helium nuclide. Is that okay? So what is the electrical charge of a gamma radiation? The gamma radiation has no charge. It has no charge, or a charge of 0. It is electrically neutral. It has no charge. Is that okay? The gamma radiation has no charge. So what will be its effect in an electric field? Since it has no charge, it is unaffected in an electric field. So we write unaffected. So in the electric field, it is unaffected. The gamma radiation is unaffected. Is that okay? Because it is not a charged particle, or it has no charge. Is that okay? In the magnetic field as well, since it is not a charged particle, it is still unaffected. It is still unaffected. Is that okay? Now, due to its electrical neutrality, it has a very high penetrating power. So in terms of its relative penetration power, it has a very high penetration power. Very high penetration power. Is that okay? So these are the 3 main radiations, and then their basic description. So the alpha particle described as the ionized helium nuclide. It has an electrical charge of +2. In the electric field, it is slightly deflected towards the negative plate since it is positively charged. Is that okay? In a magnetic field, it is still deflected due to its charged nature. It has a very low penetration effect or power. The beta radiation is described as a high-speed electron. Its symbol is drawn here. It has an electrical charge of -1. It is deflected more to the positive plate due to its negative nature. Is that okay? In the magnetic field, it is still deflected because it is a charged particle, and it has a very good penetration power compared to the alpha particle due to the mass of the 2 radiation. Comparative to the last radiation, that is the gamma radiation, it is described as the electromagnetic wave. It has no charge, it is electrically neutral, and due to that, it is unaffected by both the electric field and magnetic field, and it has a high penetration power. Now let's look at emission of alpha particle, emission of beta particle, and emission of gamma radiation as well. What is the meaning of this emission? Now let's go through that as well.